Hello again. Welcome to our channel. Today we will talk about there is a topic called from database optimizer to data science. Let's start. The title is Books and DVDs Store Example. This is the first use case. We have 50% of books and 50% of DVD in our store. Among those 50% of books, there are 90% of books in French and only 10% of books in English. And we have the opposite situation in the DVD case. So we have 90% of DVDs in English and only 10% of books of DVDs, in French. You can see these figures as follows. Let's say also that we have 10,000 articles in total. So we have 50% of books, as we saw, and 50% of DVDs. But if you take a careful look, we see that we have 50% of products in English as well, and 50% of products in French as well. So we may ask, what is the fraction of rows from our database when the language is English and the product is a DVD? How the database optimizer should proceed? I have 4 examples of SQL statement. So we want to select from test orders where language is English and products are books. The second query is the select from test orders where language is English and product is DVD. After that, we have select from test orders where language is French and product is DVD. And finally, select from test orders where language is French and product is books. So how the optimizer will calculate the fraction of rows? The first use case is with the Oracle database. For the optimizer, the estimation of fraction of 10,000 rows when querying both language and product is simple. So we have 50% of books and 50% of DVDs, and we want to query the language French, and the book and product is equal to books. So 50% times 50% is equal to 25%. If you remember the video about the base theorem, it simply says that the books, the product type of products and the language are independent events. And there is an estimation here that says that we have 2,500 of rows that will be returned. But it is wrong. Why it is so? Because there is a dependence between the language and the type of the product. That is why the optimizer is wrong. We took the same example with SQL Server. And again, the optimizer of SQL Server engine did the same mistake. So again, among 10,000 of products, it estimated only 2,500 rows when querying books and products, and querying on language and on product type. Again, it was wrong. So what should we use? What technique should we use in order to find the right solution? With Oracle, we use extended statistics and then or even dynamic sampling to solve the problem. With the dynamic sampling in our example, the estimation was much better for the small fraction. So if we ask the optimizer how much rows will be returned when the language is French and the product is DVD, this time it was a good estimate that only 100 rows will be returned. And remember, it corresponds to a small fraction that we have here, okay? And let's go further. And for the big fraction as well, the estimation was much better. So it estimated that we have 4,900 rows, and it corresponds exactly to the big fraction we have here. Remember that we have 10,000 articles in total. What about SQL Server? We put a good index on the right place, the index with the where clause for the big fraction, and we got a much better result. There was a better estimation as well as for the small fraction. Another case, we build with MongoDB database, the same example. So we are looking for the products type and the language type. But what we realized that MongoDB is always using the index if it exists, even if it is making a good estimate. So there is an estimate here. You see that MongoDB estimated that there is a big fraction and there is a small fraction. Here is this big fraction estimation, and the solution was to use the hint. And if we hint properly, then we have a good estimation. One more thing about SQL Server. If we put a good index with this where clause, we have a good histogram with a good estimation here. So, in other words, what could be the data scientist way of thinking of this? We have a product, we have a language, and we have product times language. We have dependent variables, so why not use Bayes theorem that we already saw? So the Bayes theorem, as we see here, would give the direct answer to the question. So in the case of the length, if we ask how many products of DVD type we have in French language, we obtain only 10%, and this is the right answer. So this is exactly the data scientist way thinking of this. But it seems, in example that we saw, that database optimizers still do not know too much about machine learning. Only standard statistics are still used. While waiting for the optimizers to become more intelligent and fully use machine learning, we may start to think as database scientists. The classical way of thinking when tuning with Oracle is adjusting SGA page, system global area, private global area, the parallelism, we want to create indexes, we want to create material as views. With SQL Server, we can adjust parameters with SP configure. We can still adjust the parallelism, create, rebuild an index. And every database has its own memory parameters to tune, its own parameters, memory, disks, IOs, CPUs. Those techniques will stay there. They're still very, very useful. But if you think to tune with really understanding your data, understanding cardinalities, correlation, dispersion, and even causalities inside your data, then you will be able to tune almost every database, SQL or NoSQL. Since all of them had similar principles, so once you learn them, you will be able to tune them. Thanks for watching.